Hello everyone, and welcome back to physics class. Today we're going to be looking at vector components. So we now know how to find our magnitude and direction of a vector. Now the next step we need to do is we need to figure out what the components of a vector are. So again, let's just draw an arrow, and we know that there is an angle associated with that. So this is my vector. I'm going to call it V. And when I write this, I actually want to put an arrow overhead like that. This tells me that this is a vector quantity. And then I'm going to call this angle in here theta. Now, when we're working with vectors, it's really hard to work with vectors on an angle like this. In fact, it's almost impossible to work with this. So what we like to do is we like to break them up into different components. We like to break them up into the horizontal component, which we will call Vx with the arrow, which would be this component right here. And we also like to have a vertical component, which we call Vy. And that would be this component right here. Now, if you've noticed, we've actually drawn a right triangle. If you notice that right here, there's a little right angle. Because we have a right angle now, we can actually use trigonometry to figure out formulas so that we can calculate our horizontal and vertical components. So, the formula for our Vx is actually equal to our vector times the cosine of our angle, while our Vy is vector times the sine of our angle. And these are incredibly important formulas that you should remember. So let's take a look at an example. I'm going to have this Cartesian plane here. I have my vector here, and this vector is 45 meters per second, and I have this angle in here. So my theta is 136 degrees. Now, you might be wondering, hey, Megan, this doesn't look like a triangle. Like this here looks like a triangle. Why don't I have this angle in there? Well, the reason is simple. This angle in here would still work to give you the quantities of each of the x and y, or the horizontal and vertical components. It would give you the quantities. However, it will not give you the direction, and I'll show what I mean. So let's calculate. Vx is equal to v cosine theta. Don't forget your arrows there, Megan. So 45 times the cosine of 136. When you put this into your calculator, and remember, you need to put it in degrees, otherwise you're going to get completely different answers. When you type this into your calculator, you will get negative 32.4 meters per second. Now, this is correct. The negative is actually your direction in this case. The negative tells me that this is going to the left on a Cartesian plane. Because if we remember, This is positive. This is negative. And when we're talking about anything on the horizontal, anything going towards the left will be negative. So this is actually our direction. And because this here is a vector, we need to keep this negative here so that it stays as a vector. If you ended up using this angle in here, let's call it alpha, you would get 32.4, but you wouldn't get this negative here. You wouldn't have a vector quantity anymore because you wouldn't be having the direction. So let's calculate Vy with sine. So 45 times the sine of 136, and this will give you positive 31.3 meters per second. Now, this is positive because you can see that it's actually going up. And remember, for the y-axis, anything that goes up is positive, anything that goes down is negative. So these are your answers. For your horizontal component, it's negative 32.4 meters per second. And for your Vy component, it's 31.3 meters per second. Now I want you to try it. You have this vector, it's a force vector. We know that because of the unit right here. This force vector is 17 newtons with an angle of 251 degrees. I want you to take some time, pause this video, and calculate your horizontal component for your force vector and calculate your vertical component for your force vector. All right, so let's take a look at this, shall we? Let's calculate our Fx first. So I'm going to plug in my force, which is 17, cosine of my angle, which is 251 degrees. When I put this into my calculator, I should get a horizontal component of negative 5.1 newtons. And this makes sense because if you were to draw the triangle here, this is going towards the left, meaning that your negative direction on your x-axis. So having this negative here makes sense. Now let's calculate our y. So 17 times sine of 251 should give us negative 16.1 newtons. And again, this also makes sense because if you look at this drawing here, you can see that to complete the triangle, you actually need to go down, which is a negative direction in the y-axis. So it makes sense that both of these are going to have negative numbers. Thank you for listening, and I will see you next time when we start talking about the unit vector.